Video 1.3, Natural Capital. Hello everybody, we're back for the third talk in the introductory unit on advanced environmental science. And today's talk is about natural capital. And you can see I'm wearing my Florida Everglades hat and my Maryland Biodiversity Project t-shirt because indeed biodiversity and the Everglades are both examples of natural capital. So I start today's talk with this idea. Humans depend on the resources and services supplied by the Earth's systems. And I'll ask you, does that seem self-evident to you? I don't know. Some people don't think it's self-evident. I do. So I'm wondering what you think. I think a little discussion of this will prove useful. So let's talk about it. Let's start with our food. Everything we eat is entirely based on plants and animals that were here before humans. Well, okay, I know some of you are saying, well, a lot of modern food is based on petroleum products. We eat a lot of synthetic food now. A lot of food additives are synthetic. That's true, but don't forget, they were once plants too, 350 million years ago, and it took a lot of time to turn them into delicious petroleum. Our clothing usually comes from, a lot of it comes from formerly living things. Wool, leather, cotton. Even the synthetic stuff comes from petroleum that was formerly living. Our building materials, wood, for example. But beyond wood, think about concrete. Concrete is supplied by the minerals in the earth, right? So once again, almost all our building materials are from natural processes. Of course, several of them changed by humans, but still. If we go on, the great majority of our pharmaceutical medicine is derived from products found in nature. Sometimes people find this impossible to believe, but humans didn't make up medicine. Humans merely looked at what was going on in the natural world and said, hey, that might work. So there are many examples of that. Aspirin, for example, is a naturally occurring compound in willows. Aspirin's called salicylic acid. That's its chemical name. The genus of willows is Salix. Salicylic acid derives and is connected to Salix. You probably can see that connection. And so it is this continuous operation of various planetary systems that allows human life to continue, right? Food production depends on the atmosphere, the hydrosphere, and the soil ecosystem, just to name three of the systems it depends on. So environmentalists have come to regard the resources and the systems that supply the necessities of life as natural capital. So let's look at that word natural capital a little more. What does it mean? Well, let's first look back and see where it comes from. In economics, we have this idea of capital and being any asset that is used in the production of goods or services that themselves are used to generate revenue. So factories, raw materials, the machines in the factory are all examples of capital in the broadest, most abstract sense. And we can contrast capital with income, which is the gross addition to capital, right? All the money that comes back in that we can then use to turn into more capital, or we can use for other purposes. So income is the revenue generated over a certain period of time. Does that make sense? So we now in economics have an idea of capital and income, and we're going to extrapolate them to the environment. And I just wanted to point out, as a general rule of business, the managers of a corporation want to maintain their stock of capital, unless, of course, they're corporate raiders, so that income is maintained over the long haul. I think that probably makes a lot of sense to all of you. So we'll go on from there. So natural capital, by analogy, natural capital is the stock of natural ecosystems and natural resources that exist on Earth that yield a flow of valuable ecosystem goods and ecosystem services into the future. Natural capital provides us with ecosystem goods. Think wood, Think cotton, think food, think, the various plants we use, and ecosystem services. And we'll talk more about them in a sec. So a forest is natural capital in that it can provide a steady flow of wood over time. Does that make sense to you? Right? A forest can provide a steady flow of wood. That's just one way to look at a forest, but it's the way I chose to look at it right now. And so in the forest example, what is capital and what is income? Well, the capital is the standing biomass of the forest, the whole forest that's standing there. It's the accumulated stock of material that's going to generate new productivity in the coming year, right? And the annual growth of the forest is the natural income, right? Is the income in this case. So once again, by analogy to business, to economics, we get an analogy in ecology. And don't forget that the root of economics and the root of ecology are the same Greek word oikos, which means home, right? So moving on, there are really two aspects of natural capital if you think about it. One are natural resources, useful materials and energy in nature. So the veins of copper ore or of iron ore, and the standing biomass in a forest, and the pool of oil under the ground, and all the sand on beaches that can be used to make glass, and the peat in bogs that can be used for various functions, etc., etc. Those are natural resources. Natural services are important natural processes that do things such as renew air, keep air clean, keep the right balance of gases in the atmosphere. I remember reading one ecologist talking about how if the concentration of oxygen went up too much, there would be much more combustion going on. The reaction with oxygen would occur far more frequently. And so nitrogen, even though it's inert, plays an incredibly important role in our atmosphere by reducing the amount of combustion. The renewal of water is another natural service, and the renewal of soil is another natural service. And we'll think more about this throughout the year as we go on. So some examples of natural capital, because you might say, I get this sort of, but I'd like to see some more examples. So I've got, it says the next 2 slides, but it's actually the next 3 slides. Here is someone's conception of natural capital, and I don't necessarily think this has got everything in it. But you can see the blue boxes here are natural resources, and the orange boxes here are natural services, or ecosystem services, I prefer to call them. And so a natural resource is the air, and a service is that the air provides climate control, and I would even say climate creation. The atmosphere provides UV protection, the ozone layer, for example. The atmosphere provides purification of pollutants out of the air. Water is a natural resource, and the water does things like purifies itself as it runs through the environment. And I would say waste treatment is more a property of soil than water, because water actually has limited ability to treat waste. But you can see the other things. Biodiversity is a resource, and pest control is one aspect of it. I think they've left the most important parts of biodiversity out, which is future value in terms of future crops, because crops only have a lifetime. Pests are gonna evolve, diseases are gonna evolve and ruin crops in some amount of time, and we're gonna need a storehouse of potential new crops, which are wild species now. And also pharmaceuticals, one of the biggest things. Humans aren't inventing pharmaceuticals. They're looking in plants for compounds that nature's already invented that are pharmaceutically active. So this gives you some idea of what natural capital is according to one environmental textbook. And here's another one that I love to say. Nutrient cycle is a natural service or an ecosystem service brought to you largely by microbes. Imagine what would happen if there were no microbes and the bodies of caribou and human beings just piled up and never rotted. We tend to be disgusted by rot, but it's an incredibly useful process. And in the process. Rotting material, which takes place in the soil, makes these incredibly great soils that are really great for growing plants and are rich for plants. And so microbes make soil. Soil isn't just there naturally. If there was no life on Earth, there would be no soil. There would certainly be mineral particles, but there wouldn't be soil. And then here's another conception. I think this is a little bit hard to read. I tried to find this graphic well, but I liked it. Here's somebody's idea of natural capital. And notice what they did here. They said, oh, they're supporting aspects of it, they're provisioning aspects of it, they're regulating aspects, and they're cultural. And this is something I hadn't thought about much. And these are hard to read in the middle, but maybe you can. So let's look at the cultural ones. Aesthetic, the aesthetic value of nature. And this one is recreational value of nature, right? So these are cultural values. Supporting values, creating habitat in which humans can live, photosynthesis, all the productivity on which humans depend, the formation of soil. And then food is right in the intersection between supporting and provisioning, because food, fish, clean water, provisions, wood, pollination. And if you had lived 150 years ago, there would have been a wedge here for animals, because indeed 150 years ago, much of the world fed itself on wild animals. We hardly do that at all anymore. And why is that? That's because we've reduced the annual animal population so much, we cannot do it anymore. So anyway, this is an interesting way to think about natural capital. So at this point, I think it should be obvious that human life and civilization is dependent on natural capital. It's an interesting question whether or not we can and should find synthetic, man-made ways, that's what synthetic means, don't forget, to replace natural capital. And to me, it's pretty obvious that we can't, but it's not obvious to everybody. So this led to people to say, well, how much is natural capital actually worth in economic terms? And before I give you an answer to that, I would like to just make an objection to even asking that question. And that is, some people believe that the world in which humans evolved is priceless, that we should never, ever try to evaluate it in economic terms, because that reduces its inherent value. By putting a value on it, we are economizing, as David Orr, who we'll meet in a couple of lectures, would say. And we are seeing everything in its economic terms, rather than looking for more fundamental value, more intrinsic value, more innate value. But people have done it, so I'm going to show it to you. Several studies have provided what I would say conservative estimates, and I say conservative because I'll just give you an example of this. The other day, I was telling this to my incredible office mate, Mr. Jones, and I said, look at this, the value of ecosystem goods and services, blah, and I'll show you the number in a second. And he said, conservative estimate. Immediately he said it, and he started to list off 7 or 8 things that he was sure were not in it, and he was right about most of them. Anyway, let's look at it. A 2014 paper in the journal Global Environmental Change said that natural goods and services annually were worth $124.8 trillion, which was double the world's aggregate GDP at that point, gross domestic product. So double the value of the world's economy in 2014. In 2018, World Wildlife Fund did a study, and they came up with the same number, 125 trillion. Economy had clearly grown, but that's still 10 times the US GDP. So it's huge. And as I said, these are conservative estimates. These estimates don't take into a lot. They often don't take into account the future value of natural entities, the things we will get from them in the future. So finally, I want to discuss, okay, what is some of the evidence that we actually are, as human beings, impacting the planet, right? The Earth is huge. I'm from New York, I have to say it that way. So how much of an impact could humans already have had on the planet? We're so small compared to the planet. And the answer to that is that the Earth may be huge, but the human impact is huger. So here are some examples. 12% of all bird species on Earth were deemed threatened or endangered in 2009. 12%, that's 1 in 8. Numbers are similar for all major animal groups, except amphibians, for which they're much worse. I'll bet the number in amphibians is about 30 to 40% are endangered, and the rate of extinction is by far the highest of all the 4-legged animal groups. The Earth loses 27 soccer fields of forest every minute, and that was a 2018 estimate published by the World Wildlife Fund in 2018, so data probably taken from about 2015, 2016, before the Amazon burned this fall, right? And don't forget, Brazil is undergoing a very similar type of governmental change as the United States has seen in the last 4 years, where the person in power believes that, oh, we can't really, the Earth is really there for us to use, we can't really affect it that much, and it's not terrible if we do. More than 75% of the Earth's terrestrial ecosystems are degraded by humans. This is an international panel that has looked at it. More than 75% of the Earth's land-based ecosystems are already degraded by humans. In other words, only 25% aren't degraded. Wow. Amazing. In the U.S., more than 60% of our coastal rivers and bays are moderately to severely degraded by nutrient runoff, not by development, not by other forms of pollution, not by overfishing, by nutrient runoff alone. And I put this in here because it's important for you to realize that this isn't just happening over there in other poor countries and other countries where we can't control what they're doing. It's happening at home too. The degradation is going on here. This is mind-blowing. Humans consume about 1/4 of land-based photosynthesis each year. 1/4, 25%. That means the other 2 million species, they get the other 75%. That was from the National Academy of Science in 2013. Greenhouse gas concentrations in the atmosphere have increased by 44% in the last 150 years, and carbon dioxide concentration is now higher than at any time in the last 800,000 years. Woo, doggy. That's frightening. The proposal of the Earth is so large that humans cannot or are not affecting it is overwhelmingly defeated by the data. The data shows it to be so. Why aren't people around the world on the doorstep of government demanding that this stop? And the next slide provides a graphic for some of the forms of human-caused degradation in the environment. Once again, this is someone's conception of it. We might be able to do better. Here we go. Look at this. Climate change, big one we've already identified. Air pollution, soil erosion, shrinking forests, loss of ecosystem habitats, species extinctions, depletion of underwater groundwater reservoirs, declining fisheries, water pollution, and this one, ecological simplification. So there's examples of natural capital degradation that humans are bringing about, and this course will provide you with example after example after example of just that issue. So that's the end of today's talk on natural capital. Next time, what we will be looking at is the idea that the Earth's natural resources are generated at different rates, and that's going to tell us something about sustainability. And we're also then going to now go to thinking about what sustainability means and making sure that we all have a sense of what sustainability means. So until next time, study hard.